I am using a dataset with 5 features, which I'll call x1, x2, x3, x4, and x5. Each feature represents a different characteristic of the data. Break time 200 ms. I also have a target variable, y, which is the thing I am trying to predict. Google style name enthusiastic. It's like trying to predict the price of a house based on its size, location, number of rooms, etc. Each of those things is a feature. Google style. These are the 5 different characteristics in the dataset I am using for my feature selection. Analysis. Think of them like the independent variables in an experiment. I am using a statistical method from the scikit-learn library called chi2 test. It helps me determine if each feature is related to my target variable. Break time 200 milliseconds. It's a super useful function for feature selection. The chi2 test gives me a score for each feature. These scores 0.8, 0.2, 1.5, 0.1, 2.0 indicate how strongly each feature is associated with the target variable. Higher scores suggest stronger associations. Break time 200 ms. For example, x5 has the highest score 2.0, indicating it might be the most strongly related feature. These are the actual results of the chi2 test. I'll use these to assess the strength of a relationship between each feature and the target variable. Along with the chi2 scores, I also get p-values 0.37, 0.65, 0.22, 0.75, 0.16. Break time 200 milliseconds. These tell me the probability of seeing the results I got if there were actually no relationship between the feature and the target variable. Break time 200 milliseconds. Lower p-values are better. They suggest a stronger relationship. I've set my significance level to 0.05, which means I am willing to accept a 5 chance of incorrectly concluding there's a relationship when there isn't one. Break time 300 ms. This is a common threshold in statistics. Based on the chi2 scores and p-values, I need to decide which features are important enough to keep for my predictive model. This is what I am trying to predict using my features. It's the dependent variable. Features x1 and x2 have p-values below 0.05. Suggesting a statistically significant relationship with the target variable. However, their chi2 scores are relatively low. x5 has the highest chi2 score 2.0, indicating the strongest association with the target variable. This is incorrect because feature x5 has a p-value above 0.05, suggesting it's not strongly related to the target variable, making it a candidate for removal. Features with p-values greater than 0.05 like x5 are generally considered not statistically significant and are often removed from the model. While x5 has a high chi2 score, its high p-value undermines this apparent strength, making its contribution to the model questionable. I am working with a dataset containing 5 features, which I'll call x1, x2, x3, x4, and x5. I also have a target variable, y, that I am trying to predict. These are the independent variables or characteristics of the data points I am using to make predictions. This is the dependent variable, the thing I am trying to predict using the features. Think of it as the outcome or result I want to explain. I am using a statistical test called the chi2 test to see how strongly each feature is related to the target variable. Break time 300 milliseconds. Chi2 helps me understand if there's a relationship between categorical variables. Google style name excited. It's like a detective looking for clues. Google style. These are the chi2 scores. Break time 300 milliseconds. Each number represents how strongly a feature is associated with the target variable. Higher numbers mean a stronger association. These are the p-values. Break time 300 milliseconds. They tell me the probability of seeing these results if there were actually no relationship between the features and the target variable. Break time 300 milliseconds. A low p-value, usually below 0.05, suggests a real relationship, whereas a high p-value suggests that the observed relationship could be due to chance. This is my threshold. If the p-value is below 0.05, I'll say the relationship between the feature and target is statistically significant. Break time 300 milliseconds. It's the line I draw in the sand to decide if results are meaningful or just random noise. Based on the p-values and the chi2 scores, I decide which features are most useful for predicting my target variable. Break time 300 milliseconds. I'll likely keep features with p-values below 0.05. But I'll also consider the chi2 score to see how strong the association is. I am using a dataset with 5 features, which I'll call x1, x2, x3, x4, and x5. I also have a categorical target variable, which I'll call y. The goal is to figure out which of these features are most useful for predicting y. These are the 5 different characteristics or measurements in my dataset. Think of them like different aspects of a product, for instance: price, weight, color, size, and material. I am using a statistical tool from a Python library called Sklearn. The chi2 function helps me assess how strongly each of the features x1 to x5 is related to the target variable y. It uses the chi2 test, which is great for categorical data. I've set my significance level to 0.05 or 5. This means I am willing to accept a 5 chance of incorrectly concluding that a feature is important, when it's actually not. The chi2 scores 0.8, 0.2, 1.5, 0.1, 2.0 represent the strength of association between each feature and the target. A higher score suggests a stronger relationship. The p-values 0.37, 0.65, 0.22, 0.75, 0.16 tell me the probability of observing the data if there's no actual relationship between a feature and the target. A low p-value less than my significance level of 0.05 suggests a statistically significant relationship, meaning it's unlikely we observed such strong relationship by chance. This is the overall method I am using. I am using the chi2 test to determine which features are most relevant in predicting a target variable. It's a common technique in machine learning for feature selection. I have a dataset with 5 features x1, x2, x3, x4, x5 and a categorical target variable y that I want to analyze. Break time 300 milliseconds. I am using the chi2 test from Sklearn to figure out which features are most important for predicting the target variable. Break time 300 milliseconds. I got chi2 scores and p-values as results. Chi2 scores show how strongly each feature is related to the target. Break time 300 ms. Higher is better. P-values tell me the probability of seeing my results if there's actually no relationship. Break time 300 milliseconds. I've set my significance level alpha to 0.05. Break time 300 milliseconds. This means that I will only consider feature important if there's less than a 5 chance that the relationship between it and my target variable is just random. Break time 300 milliseconds. The chi2 test gave me these results. Break time 300 milliseconds for each feature. I have a chi2 score. How strong the relationship is an AP value, the probability that a relationship is random, break time 300 milliseconds. If the p-value for a feature is less than my significance level 0.05, I conclude that there is a statistically significant relationship between that feature and a target variable, break time 300 milliseconds. It's likely not due to random chance. Break time 300 milliseconds. Based on my p-values, I will keep the features with p-values below 0.05 and discard those above it. Break time 300 ms. However, I will also look at the chi2 scores to get a better understanding of the strength of a relationships involved. Break time 300 milliseconds even if a p-value is below 0.05. If the chi2 score is very low, the feature might not be all that useful. I will select features with p-values below 0.05, indicating a statistically significant association with the target variable. Google style name excited. Let's do this. Google style break time 300 milliseconds. I am working with a dataset that has 5 features, which I'll call x1, x2, x3, x4, and x5. There's also a target variable, y, that I am trying to predict using these features. Break time 300 milliseconds. This is typical in machine learning. I used the chi2 test from the scikit-learn library to figure out which features are most important for predicting y. Break time 300 milliseconds. The chi2 test is great for figuring out the relationship between categorical variables. This is just reiterating the features and target variable in my dataset. Break time 300 milliseconds. Remember, the goal is to see how strongly each feature is linked to the target variable. These numbers show how strongly each feature relates to the target variable. Y. Break time 300 milliseconds. Higher numbers mean a stronger link. Google style name excited. X5 has the highest score 2.0, suggesting the strongest relationship. Google style. These values tell me if the relationships I see are real or just random chance. Break time 300 milliseconds. If a p-value is below 0.05 my significance level, I am confident there's a real relationship. This is my threshold. Break time 300 ms. If the p-value is below 0.05, I reject the idea that the feature and the target variable are unrelated. They likely are related. I am deciding which features are important enough to keep for my model based on those p-values and chi2 scores. Break time 300 milliseconds. It's all about finding the best balance between the strength of association, chi2 score, and the statistical significance p-value. This is the overall method I am using. Break time 300 milliseconds. I am using the chi2 test to pick the best features for my model. Google style name excited. It's a powerful statistical tool. Google style. I have a dataset with 5 features. Let's call them x1, x2, x3, x4, and x5, and a categorical target variable, which we'll call y. Think of it like trying to predict whether a customer will buy a product Y based on 5 different characteristics x1, x5. Break time 300 milliseconds. Google style name lively, pretty standard stuff. Google style. These are the 5 characteristics or independent variables that might influence the target variable. For example, they could be age, income, location, education level, and purchase history. This is what we're trying to predict. In our example, it would be whether a customer buys a product, yes or no. This is our dependent variable. Its value depends on the features. I am using a statistical test called the chi2 test chi2 from a Python library called scikit-learn. Break time 300 milliseconds. It helps me understand which features are most strongly related to whether a customer will buy. Break time 300 milliseconds. Google style name conversational. It's like a detective tool for finding relationships in data. Google style. I obtain a set of numbers that represent how strongly each feature is associated with the target variable. Higher numbers mean a stronger relationship. Here, I got 0.8, 0.2, 1.5, 0.1, 2.0. These are the actual chi2 scores for each feature x1 to x5. Notice that x5 has the highest score. The p-values indicate the probability of seeing these results if there were actually no relationship between the features and the target variable. Lower p-values suggest a stronger relationship. Here, I got 0.37, 0.65, 0.22, 0.75, 0.16. These are the p-values corresponding to the chi2 scores, telling me the likelihood of obtaining the results by chance. I've set a threshold. If a p-value is below 0.055, I'll consider the relationship between the feature and the target variable significant enough. It's like my proof bar. Break time 300 milliseconds. Google style name excited. Let's see if we meet the bar. Google style. Based on my chi2 scores and p-values and my significance level, I'll decide which features are most important for predicting my target variable. It's a crucial step to simplify the model and keep only the most relevant predictors. I am working with a dataset that has 5 features, which I'll call x1, x2, x3, x4, and x5. Each feature is a variable that I'll use to try and predict a target variable. Break time 200 milliseconds. Think of it like trying to predict whether someone will buy a product based on their age, income, location, etc. This is what I am trying to predict. Break time 200 milliseconds. It's a categorical variable, meaning it can only take on a limited number of values like yes or no, or red, green, or blue. Break time 200 milliseconds. In my example, it could be whether a customer buys a product or not. I am using a function from the scikit-learn library called chi2. Break time 200 milliseconds. It's a statistical test that helps me figure out which features are most useful for predicting my target variable. Break time 200 milliseconds specifically. It helps when the target variable is categorical. These are the results from my chi2 test. Break time 200 milliseconds. Each number represents how strongly each feature is related to the target variable. Break time 200 ms. Higher numbers mean a stronger relationship. Break time 200 milliseconds. I have scores of 0.8, 0.2, 1.5, 0.1, and 2.0 for my 5 features. These tell me how likely it is that I'd see these results just by chance, even if the features and target variable are not really related. Break time 200 milliseconds. Lower p-values are better. They indicate a stronger relationship. Break time 200 milliseconds. I got p-values of 0.37, 0.65, 0.22, 0.75, and 0.16. Break time 200 ms. Remember, p-values are probabilities, always between 0 and 1. This is my threshold for deciding if a relationship is real or just due to chance. Break time 200 ms. I've chosen 0.05 or 5. This means that I only consider a relationship significant if there's less than a 5 chance that it happened randomly. Break time 200 milliseconds. This is also called alpha. Based on my chi2 scores and p-values and my significance level, I decide which features are important enough to keep when I build my prediction model. Break time 200 milliseconds. It's a decision based on statistical significance. These are the individual characteristics or variables I have in my dataset. Break time 200 ms. They are the potential predictors of my target variable. Break time 200 ms. They could be anything that describes my data. For example, if I am trying to predict if a customer will buy a product, they could be age, income, education, etc. The overall goal of my analysis is to select the features which are most useful to predict a target variable using the chi2 test. Break time 200 milliseconds. This is a statistical technique used for feature selection in machine learning when dealing with categorical data.